The subject we decided that we would like to look at today is an issue that I'm sure many of you will have faced. The problem of tuning a database for two different workloads. And we're just going to call them OLTP as against DSS. The idea is that within your database, you've got some users, some types of work that are all about short transactions, little queries. And at the same time, you've got some work that's doing quite big stuff, maybe big queries, big batch jobs, whatever. And it can be very difficult to tune the two. So we'll go through what that problem might be and the issues that sort of problem can cause. And then we'll move on to a possible solution, which is the use of materialized views. Now, Dave and I were having a chat before we started about how far back, what releases did these capabilities come in. And materialized views are certainly not new. They've been around for many, many releases. But they're continually being enhanced. And the very latest release, they're 12.2 and later, there's some significant improvements. But they can be really difficult to get right. They can be really difficult to get them working the way you need them to work, particularly the refreshing capability. And even if you do get your refreshing working, it may not be good enough. So we'll describe the issues you get there. We'll move on then to the on-commit refresh, which can be very good, but it has its own issues. And then finally, the new feature, the real-time refresh capability. One thing I would like to mention, by the way, there's the package DBMS MView that does have the procedure DBMS MView explain MView. And explain MView, I'm going to be using that a fair few times. It's a very useful tool indeed to help you. It's like a wizard or an assistant that will help you get your materialized views to work the way you think they should work. So that's our agenda. Beginning with, what's the actual problem? Tuning for OLTP or DSS. And so many of us have to do this. Think of even something like Oracle e-Business Suite. It's one database, and you've got all your forms users bunging in the transactions, and at the same time, you're running your reports against it. Classic case of how can you tune it to support both workloads. And on this slide, we put up a couple of the sort of problems that one gets. Now, OLTP, what does that mean? Well, typically, small transactions, small queries. You'll be using B-tree indexes. You'll be having normalized data structures. You won't normalize data structures, which will give you optimal performance for high transactional workload, high concurrency. But in your data warehouse, where you're tuning for different types of work, you would take a totally different approach. Instead of lots of B-tree indexes, you would likely have bitmap indexes. Instead of normalized structures, you'll have denormalized your tables into a star schema. Oracle really doesn't like you to use snowflakes. You want to denormalize your dimensions into a single level dimension in a star schema, and Oracle has all sorts of capabilities for doing that. But then if you try running a transactional workload against denormalized structures with bitmap indexes, the results may well be disastrous. So this makes it's a very difficult decision. You can tune for OLTP and have really bad query performance, or you can tune for query performance and OLTP may suffer. Or you may end up with neither running well. So one will be slow, the other will be slow, or both will be slow. Bottom bullet point adds another degree of complication. I've mentioned the partitioning strategy here. In an OLTP environment, you'll probably be wanting hash partitions and local indexes. That should maximize concurrency and performance of small queries that retrieve small row sets. In DSS, you'll be more likely going for range partitioning and, of course, global indexes. A partitioning strategy that fits one type of workload may be disastrous for the other. Some of our materialized view facilities may help resolve this sort of problem.
just like to mention, John, I've put into the chat what I hope is helpful. It's a tutorial that you created from a previous webinar, how to convert non-partition to partition in database 12c release 2. So,
yes, that's an interesting. I'd forgotten about that. Well, I can almost see why Oracle created that. You can also convert your partitioning type as well. The number of partitioning disasters I've seen where the strategy turned out to be inappropriate. Get partitioning right, the results can be brilliant. Get partitioning wrong, the results will be a disaster. It is now at least much easier to change your partitioning strategy if you did make a dreadful mistake. So, can materialized views help with this sort of problem? Well, before diving into what they can do, I do want to spend a bit of time just in effect to make sure that we are all on the same page of the manual. I want to make sure that we are familiar with what materialized views are, simple syntax for creating them, and then move on to query rewrite, how it can actually work and how it can benefit your application. Now, the idea is there's a materialized view is a pre-computed result set, and it's stored in a segment. Basically, it's a table. Now, that pre-computed result set is based on a query, and it could be a pretty big query. It could be a query that joins 50 tables. It can do denormalization. It can be doing the aggregations, the column projections, everything. So you take some massive query that might take minutes, even hours to run, and you save the result set. So selections, joins, aggregations, column projection, everything gets saved as a table, as a segment, or possibly multiple segments if it's partitioned, but it gets saved as a database object, a data object. The materialized view container table is in many ways a table like any other. It can be indexed. You'll certainly want a primary key index on it. It can have secondary indexes, composite indexes. It can be partitioned. In many ways, it can be managed like any other table. And the indexing and partitioning does not have to bear any relationship to the indexing and partitioning strategy that you have on the detail tables from which it is derived. So it can be tuned in ways that will optimize it for query processing. Then you get the clever bit, the query rewrite. Your end users issue a query, your application issues a query, and that query will be addressing the detail tables, the tables that are published, visible to the users. The query will be joining emp to dept, for example, to take a trivial example. If the optimizer realizes that there is a materialized view that has already got the stored results set of joining emp to dept, then the cost-based optimizer can rewrite the query to address the materialized view. It's that simple. It's a transparent rewrite, happens in the background. There's not. Yes.
Oh, I'm sorry. What's the licensing implications of materialized views? In other words, cost.
Ha 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 ha. If I were a salesman, I'd be rich. My understanding of this is that materialized views, basic materialized views, are available in standard edition. But to get the rewrite capability, you need enterprise edition. You need enterprise edition licenses. But there are no options needed on top of that.
Great, thank you, John.
Now, so it's a cost-based optimization, completely transparent to the user. So let's see how it actually works with a couple of simple examples. Now, for this demonstration, I'm going to work on a copy of the sh.sales table. But I'm going to make one modification. Oh, so here I'm logged on, by the way, as I'm just working in the Scott schema, absolutely normal out-of-the-box database, no patches applied. So I'm going to create a copy of the sales table. Create table sales as select row num sales.star. You really do need a primary key when you start working with materialized views. And as I'm sure many of you will be aware, sh.sales doesn't have a primary key. So I'm going to add just a row num column, and I shall declare that as a primary key. Right, it's a very simple example. So I've got a table, just a facts table with a primary key. You can't do much without primary keys. The query I'm going to use is a very simple aggregation. I'm just going to be running this. Oops. All I'm going to do is sum up the amount sold per channel ID. Right. Well, in case any of you are not so familiar with the demonstration schema, the sales table, there's my primary keys I've added to it. It's a facts table with these dimensions and these two measures. So all I'm doing is summing up the amount sold column per channel ID. And the channel ID is a foreign key to sh from sh.channels. So that's my basic query. Well, how's Oracle running it? Well, we'll just enable auto trace. And there aren't really any options. It's had to do a full scan of sales, costed at $14.84. Right. Now, could a materialized view help this? Here's the basic syntax. And those of you who know this backwards already, please forgive me for going through it. I just want to make sure that we are all aware of what's happening here. Now, create materialized view, I'm calling it CSUM, enable query rewrite. Those are the critical keywords that enable the rewrite facility that, as discussed in a question earlier, that you wouldn't have in standard edition. But this will allow the cost-based optimizer to rewrite queries to the materialized view if it thinks it should. And then you give it the select statement. Now, in the real world, that might take hours. If it's a complex view that's joining zillions of tables, doing all sorts of aggregations, heaven knows what else, that's the query, the creation of the object, that could take a long, long time. If I now run my query again, right, well, remember previously, full table scan of the sales table, costs at $14.84, run it now, well, knock me down with a feather. I've addressed the sales object. In the background, it's been rewritten to address my materialized view. And the cost, of course, has come down massively. Right, so that's the basic objective. Note that in my example here, the query I ran was exactly the same as the query on which the materialized view was based. That doesn't have to be the case. The optimizer is pretty clever. And to take a slightly more complex example, select channel desk, some amount sold from sales join SH channels using channel ID where. So a slightly more complex example, I'm joining my facts table to the dimension table on the primary key, foreign key, and I put in a filter as well. And what we should see, we've still got the materialized view rewrite coming in. So the optimizer is very clever about this. It's a costed transformation, and statistics clearly are vital for this. But Oracle has worked out that using some sort of subset of that materialized view, it can still satisfy that query at a far lower cost. For comparison, that was cost at 7. For comparison, if I told Oracle not to do it, /star plus, just give it the no rewrite hint until it's don't do a rewrite. Aha, cost goes through the roof. And now we're actually running the query for real. So that's the basics of query rewrites. The materialized view is an instantiation of the query. And you create as many materialized views as you want, trying to make them as general purpose as possible. You don't want to write a materialized view specifically for one query. You want to design an M-view, a materialized view, that can be used for many, many queries, and trust the optimizer to make use of them as it thinks best. Now, but there are some problems. What about DML? This has always been the problem with materialized view and query rewrite. Oracle uses the term stale to describe a materialized view that's out of date. Now, if I do pretty much any DML at all, well, not just I, but anyone does any DML at all, let us say, very simple query update sales, set amount sold equals amount sold plus 1, where ONUM equals 1. So I'm just doing a tiny little transaction against my facts table. 1 row updated. Now, I'll run that same query again. Remember, this query before that joined sales to channels with a filter and so on, with an aggregation and a filter, was rewritten and costed at 7. I'm now done, or anyone does some DML against the table, and then when we run the query, set interface. Oh dear. The slightest change to the data and the rewrite fails. And that is because by default, Oracle will not rewrite to a view that's out of date. And it is. The view was created, the materialized view was created before I did that DML. It's got out of date data in it. So Oracle, default configuration, will refuse to do the rewrite. Now, you can control that, by the way. There's that parameter I've mentioned here, query rewrite integrity. If you look at that, the query rewrite integrity instance and session parameter defaults to enforced. And that means that the optimizer will never do a rewrite if it cannot guarantee that the materialized view has current data. And that clearly is a sensible default. Yeah. So out of the box, by default, Oracle will never run a query in a way that will give you an incorrect result. If you don't mind your queries hitting old data, you can change that. I could alter, I'll do it at the session level, set query write integrity.
Just answered my question, John. Thank you.
Yes, stale tolerated. Sorry, I preempted that one. All right. We can see I'm playing games with the optimizer here, by the way. There's no guarantee that any of these demonstrations will actually work. But having done that, if I now run the query, it did, right? And note the results is ever so slightly different. 61, 60. And that's because having given Oracle permission to rewrite for performance reasons, even though CSUM is out of date, we now get that stonking performance, and the price we're paying is that is a bit out of date. Right. I'm going to put the parameter, however, back to enforced. Many sites will be able to run with that parameter on stale tolerated. In effect, it could mean if you refresh the materialized view, say overnight, it would mean your queries would be rewritten to the data as of yesterday evening. And that will be acceptable for many sites. But I'm going to assume we want to have real-time information for the rest of our time together today.
So we've got a couple of questions in the queue. First, I'll start at the bottom. Would developers have some sort of warning when viewing the explain plans? And I assume Michael means warning that it's not using the MView.
What you would see is that keyword there, material mat view rewrite. And if you're not getting that, then it's going straight to the detail tables.
Yeah, so it's not a clear warning. You've got to know you've got to know the red flags, as I like to call them, what you're looking for. And the red flag is the absence of mat_view here.
That's correct. That's correct. Yeah. And it can, by the way, be very difficult to work out why your rewrites are not working. And this business of the materialized view being stale is a pretty obvious reason. There are lots more subtle reasons why some queries cannot be rewritten. The complexity of the query is very significant. The cost-based optimizer will do its job. It will do what it can, but it can't rewrite everything in all circumstances.
Would we get a warning if a query returned stale data?
No, you won't. If you've permitted your session to accept stale data, you will not know it.
And something you're about to speak about, I believe, complete refresh. Can you create an index on a materialized view with the complete refresh setting? You might want to start as to what refresh is and then go to that question, but thanks.
Let's do the refresh first. Complete refresh implies, as the name implies, you rebuild the thing completely. You do it with the package DBMS MView. And this is, if you look at it, describe DBMS MView. It's a huge and horrible package. And refresh. It's not too badly overloaded, just 2 versions. But give it a list of MViews and their defaults for everything else. I'm going to give it the name of my materialized view and a method. Right. There are other variations, refresh them all, refresh dependents. Yeah, there are quite a few variations here, but I should use just the most basic one. Now, this syntax here, DBS MView.refresh, the name of the view I want to refresh, and then C. C stands for complete, and that is the type or the method of refresh. And C for complete is going to truncate the materialized view segment. Remember, it's a table in effect. So the container table will be truncated and repopulated by running the query from the beginning. That might take hours. That might take hours. You need to think of the impact on your system while that's going on. Now, if that takes hours, fine, but then your queries will be correct. And the refresh and the rewrites that might have been stopped before will now go through successfully. So that's the complete refresh. Is not acceptable in most environments. It takes too long. What we need is what Oracle calls the fast refresh. Now, the fast refresh relies on capturing changes. So when you do your DML against one of the detail tables, any DML that hits a detail table, such as that, we capture the change and write it to a log, to what is called the materialized view log. Then the log gets merged into the view. Well, I know what to do here, but let's pretend I didn't. If I want to see if that view is refreshable, there's a very useful procedure in DBMS MView, the wizard that tells you what's going on. Now, there's a bit of preparation needed. I'll just show you the procedure. It is the explain MView. Explain MView. Note, overloaded. But they're all more or less the same. You run explain MView, giving it the SQL statement that you want it to investigate. And it will tell you what's going on, what that view is capable of. To run it, you have to do a bit of preparation. There's a script, rdbms admin, utlxmv. That creates the table where the wizard will write out its results. And it's just this little table here. It says, well, that's materialized view. These things are possible or not. And there's some helpful advice as well. So let's see what the advisor is telling me about my view here. So simplest possible syntax. exec, demus mview, explain mview, and there's my materialized view statement. Select channel ID, sum amount sold and sales, group by channel ID. Done. And then query that table to see what that view is capable of. I'm just going to look at what is possible and any helpful advice for a materialized view based on that query. Oops, I'll just set the auto trace off, so we don't want auto trace for that. And I'll also format a couple of columns and try again. That's more like it. So I've got 17 possible capabilities. There are some duplicates here. Now, that's partition change tracking. That is not possible. There's no partitioning involved in this. Refresh complete is possible. You saw me do it. That was the complete refresh that I ran a moment ago, and I gave it a complete refresh. Complete refresh is certainly possible. Fast refresh, which applies captured changes, is not possible. Rewrite is possible because of the syntax I used when creating that thing. I would have said enable query rewrite. That's again partition change tracking. And then we get a load of ends, things that aren't possible. Various types of DML will mean that you can't refresh the thing afterwards. I can't do a fast refresh after any of these. But the most basic problem is that there's no materialized view log. Right. So it's that straightforward. I need a log to capture the changes. Here you see the rewrites coming through, full text, partial text, and so on. But I need to create a log, and that's coming straight up there. The detail table does not have a materialized view log. Of course, if the query were based on we're joining 20 tables, they would all need to have logs. So I'll create a log. Again, building it up slowly, most basic statement. Right. Another thing here, we see that the object itself, it doesn't have a log, but there's a bit more. I need to have some extra columns in the view. Oracle needs to know I've got the sum, I'm summing up a value without counting it. I'm also not counting the number of rows going into it. Oracle wants me to add these things. Then we might get some fast refresh coming through. So try again. I'll truncate my MV capabilities table. Now I've got a log. I've got the log, which it told me to create. I'm also adding the sum of amount sold to my query and the count. That was the count of amount sold, the sum of amount sold. It also wants count star, so I put count star in as well. So our materialized view now has just a couple of extra columns. Does that make it more successful? Let us see. Go to materialized view capabilities. Ooh, let's see. I still can't do refresh fast because we need a row ID. We need new values. So I've sorted out the problems with the materialized view not having enough columns. Now the advisor is telling me the log needs more columns. Okay, try again. I'll drop the log. And then we'll add some extra columns to the log. And I'll try to push this along to make sure we don't run out of time. So my materialized view log now includes row ID and the columns it's complaining about. Right. Try again. And, oops, I'll need to truncate the table first, sorry, truncate. Then run the advisor again and see what it comes up with now. That looks good. I've got refresh fast is now possible, rewrite is possible, I can do refresh after insert and so on and so forth. It still can't do anything. The only no's are now for partition change tracking. Everything else is now a yes. Good. So that's got it working, and I can now do fast refreshes. Now, just as a proof, I'll create the materialized view, actually create it. Oops. So I've created the materialized view with the extra columns, and now it should be fast refreshable. So as an example, we just make sure it really does work, and then we'll move on. So if I run my query, I get the rewrite, do my DML, I've done my update statement, run my query again, and it gets not rewritten anymore. So that query all of a sudden took half an hour because there had been the DML and had to go to the detail table. But I can now do a fast refresh. There's your syntax, which is DMSM view refresh. This view I created, which I called fast CSUM, remember? Fast CSUM. And that one, I've told refresh method F for fast, and that succeeds. And that might take only a couple of seconds, whereas the full refresh, the complete refresh, might take hours. And now I get my rewrites. So that's the basic of it. Stale materialized views have to be refreshed. And it can be pretty difficult getting the fast refresh to come through. But it's hugely faster than the complete refresh because all it's doing is merging in changes that were captured in the log.
Question on the complete refresh, John. Can we create an index on an MView with complete refresh?
It won't help with complete refresh. It won't help at all. The complete refresh does replace the materialized view contents completely. So any indexes you create on it will survive, but they're not going to help. They're not going to reduce the time that it takes to actually accomplish.
Thank you.
Okay, even this though, how often do you fast refresh? Well, you might be able to do a refresh every couple of minutes. But even so, you've got a problem that is out of date for a while. And that's where you have real-time results. There's the refresh mode on commit. Right, that's if you can't handle any lag at all. Right, so what if you have to have up-to-date data? In that case then, you can do it with OLTP Materialized View, fast CSUM, refresh on commit. And that changes the mechanism completely. But now we should always get rewrites. For example, I'll run my query. That had a rewrite. Then I'll do an update. I've done an update, and I'll commit it. And now we can run my query again, and I get the rewrite. And if you bother to check the details, we'd see they are in fact correct. So there is a workaround. Refresh mode on commit guarantees the queries will be correct. But there's a problem. Your DML performance is now going to degrade because your transaction is now no longer updating just the sales table. You're also updating logs, you're updating the materialized view. Before, to get the correct results, your transaction is now doing a lot more work, and it's synchronous. So this works, but your performance may well now degrade. And thanks to 12.2, there is now a solution.
Thanks, John. Quick 30-second break. John, get a glass of water. Just a reminder, give us a call at Skibbleders if you need some administration services, be it some small tasks that we can offload for you or a large project that we can assist you with. Love to do it. And if you go to our website, skibbleders.com, and look under our services, you'll see all of the things that we have done, the services we offer, and not only DBA services, but Apex as well. And a little bit of a value add here is we're certainly helpful in that we can mentor your team as we implement a solution. So you're not left wondering how it was implemented. You know how it's implemented, and you can manage it yourself down the line if you so desire. We can also bring in the developer team for help so that both sides of the fence are covered. and your developers are working in concert with your DBAs. Often very critical for tuning. Okay, thanks. Back to you, John.
Okay, thanks for the break. Now, so what I've outlined so far is what you would do with materialized views until quite recently. Now we have the new feature of 12c release 2, 18, 12c, obviously 18c, 19c as well. Now, you can still have scheduled fast refreshes. I remember in the days of using materialized views for replication, which is still fully supported and very powerful, by the way, with materialized view replication, I would sometimes refresh perhaps every 3 minutes. And that still works. But what if 3 minutes isn't good enough? Either your queries won't get rewritten, or you'll have to set stale tolerated. So if that isn't enough, you would have to resort to the refresh on commit, which have problems. That's now fixed, because we now have the capability for the results set to be refreshed in real time as necessary for your query. Very powerful capability. When you run your query, the cost-based optimizer will detect that the materialized view is out of date or stale. But rather than hitting the detail tables, it will dynamically merge the changes that have accumulated in the logs into the result set. This is a very powerful capability. So let's see it. First off, I'll just disable the on-commit refresh and go back to refresh fast on demand. Refresh fast on demand means the refresh will only occur when I explicitly invoke dbmsmview.refresh. In the real world, you'll be scheduling a refresh, which could be every few minutes, or it might be once a day, but it would almost certainly be a scheduled job. Now I'll enable the new capability. Alter materialized view, whatever it was called, enable on-query computation. That's our new syntax. And let's see what happens. I'll run a query, which is my usual one. Remember, I'm using a simple query, but it doesn't matter. I could be joining it to other objects. I could be doing all sorts of aggregations and so on, but I'm just doing the most basic example here. So run that query, and I get the rewrite, costed at 3. Whereas remember, without the rewrite, it was coming through at about 1400 odd, wasn't it, without the rewrite. Now I or anyone will do some DML. Doesn't matter which session does it. That materialized view is now stale. I've done an update. That materialized view is out of date. Right. And I've disabled the on-commit update. That materialized view is out of date. If I were to query the container table directly, we would see that. But I'm going to write my query that hits the detail table. Going to sales. Way, look at that. So the result, well, that was 42.32. It's now, one of them will have changed, 260264. Oh, that's the one. It's row 3. That was 63. I've done the update. It's now 64. So I've got new data coming through. I've got new data. I'm getting the current data, but I'm still getting the rewrite. Now this plan looks a bit horrific, but it's a good thing. Note the cost is 18. The cost has definitely gone up from the cost of 3, but 18 is still a lot less than the 1400 odd it was if I go straight to the actual detail table.
Boy, the plan looks scary. It looks like it'd be a million.
Indeed, indeed. But isn't this so often the case? The optimizer is cleverer than us. Just because there are 26 operations in this plan doesn't mean it's not a lot faster than if I did it like this, /star plus no rewrite. And that may be a simple plan, but look at the cost. Nice. So what's going on? Well, we can't go through all the detail of this, but you can, but you can reverse engineer it and get some sort of idea of what's happening. You can see the rewrite to the materialized view. It's come through there, and we see it again there. But at that time, we're getting in with an index. So we appear to be doing a full scan of the materialized view and an outer join to the view log. So you can see here the beginnings of merging the out-of-date materialized view with the changes captured in the log table. And that is then being union-alled with more access to the log. And then again, a merge join there to the log again. So these operations here will be merging in, adding in inserts that are not in the view, removing rows that were deleted, and updating rows that were updated. So
John,
you could,
those are the three operations against the log. Can those operations, the results of those operations, sort of be saved and shared across sessions?
unfortunately not. Certainly in the current release, you run the query, the optimizer, presumably during the soft part of your query, realizes that it could rewrite it and it will be cheaper to rewrite it, but it's out of date. And for your cursor, this merge happens. And if another person also runs a query that can be redirected to the materialized view, his session is going to have to do the same work. So the results aren't shared. You could share it with the result cache. I have tested that. It's a cacheable result if you were to enable the result cache, but it's done in real time for each session. Never mind, it's still going to be a lot better than going to the detail table.
Yeah,
so merged in transparently.
I'm sorry, John. Result cache is a great solution in a sense, a great way to implement that in a data warehouse environment.
I think it certainly would be. And remember how easy it is to use the result cache. I don't know if we have any tutorials online for that, but if I were to, I'll do it at the session level rather than risk damaging later demonstrations. If I were to put that to force and then run my query, right? So my query, you see there, rewritten again. So even though that's exactly the same query I ran before and the data has not changed, it's the same plan coming through, costed at the same price. But if I run it again, now we see the result cache coming there. So it definitely works. And that cache result would be shareable across sessions. And that would actually work together quite well. I can see a case for enabling that, simply to reduce the workload of merging in the results.
We did have a tutorial on result cache, but I can't find it right now. But if I find it, I will post it to everybody after the webinar.
Because if you could do that, I mean, just using the materialized view might bring your query down from half an hour to 30 seconds. Adding the result cache is going to come down from 30 seconds to 1/10 of a second. So that's the new capability, the ability to merge in changes in real time. You will still need to refresh, but how frequently you refresh, whether it's every 10 minutes, every hour, clearly the longer the gap between refreshes, the more work will be necessary when you're doing this lot. But even so, the results are going to be astronomically good. So in effect, you can design your database for both OLTP and DSS. The way I've been demonstrating it, I'm assuming it's the DBA who does this, but clearly developers need to have a massive input to it as well. But the idea is it's transparent. The developers write code that fills the business need, and I, the DBA, configure my materialized view strategy to optimize those queries to run really well. OLTP will always hit the tables, and they can be optimized accordingly with partitioning and B-tree indexes and normalized structures. The DSS type queries will be transparently written to the MVs, the materialized views, which are structured appropriately. That's not new. What is new is what if the fast refresh just isn't fast enough? Well, that's real-time materialized views. They aren't necessarily straightforward to configure. believe me. And clearly the examples I've been going through today are pretty simple. But overall, I think it's a big technical advance.